Have you ever wondered what conjugate acids and conjugate bases are? To understand them, let's first define acids and bases. Acids are chemicals that increase the concentration of hydrogen ions or protons in an aqueous solution. For example, HCl is a strong acid with a pH of 0 to 1. In an aqueous solution, it dissociates into hydrogen ion and a chloride ion, which increases the concentration of hydrogen ion in the solution. Bases, on the other hand, are chemicals that decrease the concentration of hydrogen ions in an aqueous solution. They normally do so by releasing their hydroxide ions that bind with the hydrogen ions in the solution to give water molecules. In this way, hydrogen ion concentration from the solution is decreased. Have you noticed that while defining acids and bases, the terms hydrogen ions and protons are used interchangeably? The reason is that in the structure of an atom, we have a nucleus which have protons and neutrons inside it, while the electrons revolve around the nucleus. For example, this is a structure of a helium atom that has two protons, two neutrons, and two electrons, while hydrogen atom is a little bit different. Inside the nucleus, it has only one proton, while one electron revolves around it. So when it loses its electron to form a hydrogen ion, what we are left with is just a proton. That's why hydrogen ion is also known as a proton. Moving back to the acids, the HCl in a solution exists as H plus and Cl minus ions, which means that the Cl minus ion can potentially combine back with a hydrogen ion to form HCl, decreasing the concentration of hydrogen ions in that solution, which means that this chloride ion is a conjugate base of HCl. Now note that HCl is a strong acid, which means that it's more likely to exist as hydrogen and chloride ions, which makes this chloride ion a weak conjugate base. Let's take another example of acetic acid. It has a pH of 2.4, making it a weak acid. In an aqueous solution, it dissociates into acetate and a hydrogen ion. Acetate is the conjugate base of acetic acid. Now, acetic acid is a weak acid, which means that acetate is more likely to combine with a hydrogen ion, making it a strong conjugate base. Now, this is a general rule. Strong acids have weak conjugate bases and weak acids have strong conjugate bases. Now, let's look at bases. Sodium hydroxide, for example, is a strong base with a pH of 14. In an aqueous solution, it exists as a sodium ion and a hydroxide ion, which means that the sodium ion is a conjugate acid of NaOH, which can potentially combine with this hydroxide ion to give back NaOH. Now, since NaOH is a strong base, which means that it's more likely to exist as sodium and hydroxide ions, which makes its conjugate acid weak. The same general rule applies here as well. Strong bases have weak conjugate acids and weak bases have strong conjugate acids. I hope this helps. Subscribe!